The greatest gardeners in history never owned a single bag of fertilizer. They never consulted a soil chart or purchased an amendment from a garden center, and yet they grew food that sustained entire civilizations for thousands of years. Their secret was simple. They understood their soil. They listened to it. They worked with it instead of against it. And somewhere along the way, we forgot how to do that. We forgot that the answer to nearly every gardening problem lies beneath our feet. This is the story of soil testing, and it might be the most important gardening skill you never learned. Most gardeners approach their soil the same way. They dig a hole, they plant something, and they hope for the best. When plants struggle, they reach for fertilizer. When leaves turn yellow, they add more nitrogen. When tomatoes develop blossom end rot, they assume calcium deficiency and start adding amendments. But here is the truth that changes everything. Adding nutrients your soil does not need can be just as harmful as having deficiencies in the first place. Excess nitrogen causes leafy growth at the expense of fruit. Too much phosphorus locks up zinc and iron. Improper calcium ratios affect magnesium uptake. You can spend hundreds of dollars on amendments and actually make your soil worse. This is why testing matters. This is why understanding your soil transforms everything. Let me take you back to the fundamentals. Soil is not just dirt. It is a living ecosystem containing minerals, organic matter, water, air, and billions of microorganisms. The United States Department of Agriculture estimates that a single teaspoon of healthy soil contains more microorganisms than there are people on Earth. These bacteria, fungi, protozoa, and nematodes form complex relationships with plant roots. They break down organic matter. They convert nutrients into forms plants can absorb. They protect against pathogens. When we ignore soil biology and focus only on chemical inputs, we disrupt this ancient partnership. Testing helps us understand what our soil actually needs rather than guessing and hoping we get lucky. There are two fundamental approaches to soil testing. The first is professional laboratory analysis. The second is home testing. Both have their place, and understanding when to use each will save you time, money, and frustration. Professional soil tests examine your soil with precision that home kits cannot match. They measure pH levels, nutrient concentrations, cation exchange capacity, organic matter percentage, and sometimes even biological activity. The cost typically ranges from $15 to $50 depending on the detail level you request. For this investment, you receive specific recommendations tailored to your soil and your intended crops. If you are establishing a new garden, converting a lawn to growing space, or experiencing persistent problems despite your best efforts, professional testing is worth every penny. The major land-grant universities in the United States operate soil testing laboratories as a public service. Cornell University, Penn State, the University of Massachusetts, Texas A&M, and dozens of others provide this service. Many offer specialized tests for home gardeners at reduced rates. The process is straightforward. You collect soil samples from your garden using a clean trowel or soil probe. You gather samples from multiple locations within each growing area because soil composition varies even within small spaces. You mix these samples together in a clean bucket, remove about 1 cup of the combined sample, let it dry if it is wet, and mail it to the laboratory in the container they provide. Results typically arrive within 2 to 3 weeks, but professional testing is just the beginning. Home testing gives you the ability to monitor your soil throughout the season and make adjustments in real time. The most essential home test requires no equipment at all. It is the squeeze test for soil texture. Take a handful of moist soil and squeeze it firmly in your palm. Open your hand. If the soil holds its shape and does not fall apart when you poke it, you have clay soil. If it crumbles immediately when you open your hand, you have sandy soil. If it holds its shape briefly but breaks apart when poked gently, you have loam. The ideal balance most gardeners seek. Soil texture affects everything. Clay holds nutrients and moisture, but drains poorly and compacts easily. Sand drains quickly and warms early in spring but loses nutrients rapidly. Understanding your texture guides every amendment decision you make. The jar test reveals soil composition with greater precision. Fill a clear jar 1/3 full with soil from your garden. Add water until the jar is almost full. Add a tablespoon of dish soap, which helps separate the particles. Shake vigorously for several minutes, then let it settle for 24 hours. You will see distinct layers form. Sand settles first at the bottom within minutes. Silt forms the middle layer over several hours. Clay particles, the finest of all, form the top layer and may take a full day to settle. The proportions tell you exactly what you are working with. Roughly equal parts of sand, silt, and clay indicate loam. Home pH testing kits provide another crucial piece of information. Soil pH measures acidity or alkalinity on a scale from 0 to 14. Most vegetables thrive between 6.0 and 7.0, slightly acidic to neutral. Blueberries prefer acidic conditions around 4.5 to 5.5. Asparagus tolerates alkaline soil up to 8.0. When pH falls outside the optimal range for your crops, nutrients become chemically unavailable even if they exist in abundance. Iron deficiency in plants often results not from lack of iron but from pH conditions that lock iron into unusable forms. Testing pH before adding amendments prevents wasted effort and expense. Now comes the question every gardener asks. How do I fix what the tests reveal? Soil amendment follows logical principles. Once you understand what you are working with. Heavy clay soil benefits from organic matter, coarse sand and gypsum, which improves structure without altering pH. Sandy soil needs organic matter to increase water and nutrient retention. Compost addresses nearly every textural extreme because it improves both drainage in clay and retention in sand. For pH adjustment, sulfur lowers pH gradually over months, making soil more acidic. Lime raises pH, making soil more alkaline. Always apply these amendments, based on test results and recommended application rates. More is not better. Overcorrection creates new problems. The biological dimension of soil health deserves equal attention. The soil food web depends on organic matter as its energy source. When we add compost, aged manure, leaf mold, or cover crop residues, we feed the microorganisms that make nutrients available to plants. Chemical fertilizers bypass this system entirely. They provide immediately available nutrients, but do nothing to build long-term soil fertility. Worse, high salt concentrations in synthetic fertilizers can harm beneficial organisms. Organic amendments work more slowly, but create self-sustaining fertility that improves year after year. Timing matters for soil testing and amendment. Test in fall when possible. This gives amendments time to integrate before spring planting. Lime and sulfur need months to alter pH. Compost benefits from winter freezing and thawing cycles that incorporate it into the soil structure. If fall testing is not possible, test as early in spring as soil conditions allow. Avoid testing immediately after adding fertilizers or amendments, because results will not reflect true baseline conditions. The greatest gardens in the world share one common element. Their creators understood that healthy soil produces healthy plants without constant intervention. Every hour spent understanding your soil saves dozens of hours fighting problems that proper preparation prevents. Every dollar invested in testing saves many dollars wasted on unnecessary amendments. The answers you seek are not in the garden center. They are beneath your feet, waiting to be discovered. Start with a professional test to establish your baseline. Learn the simple home tests that let you monitor changes over time. Add organic matter consistently. Adjust pH only when tests indicate the need. Build the living soil ecosystem that sustained agriculture for 10,000 years before synthetic chemicals existed. Your plants will respond with vigor you never thought possible. Your harvests will improve. Your gardening will become easier. Because you finally understand the foundation everything grows from.